in astronomy, we have to deal with big numbers, really big numbers. There's just no getting around it. So here are a couple examples. This number, this is a 6 followed by 24 zeros, is the mass of the Earth in kilograms. A kilogram is half of a 2-liter soda bottle. And that's the mass of the Earth in kilograms. This number here is 150 million in kilometers. That is equal to 1 astronomical unit. That's the distance unit that we use within the solar system, the average distance between the Earth and the Sun. If you think that's big, that's small compared to a light year. And so in kilometers, that is 1 LY for light year. And I think you can pronounce this 9.5 quadrillion kilometers is 1 light year, the distance that light travels in a year. And so look at all those zeros. It's really hard to keep track of all those zeros, which makes it really, really easy to mess up. And so we're going to use what's called scientific notation to make it so that we're not keeping track of all these zeros, all these decimal places and place values. And so I've got two examples here that are not astronomical in nature. 450. 450, that is the number of snakes that were used in the filming of Snakes on a Plane. And so 450. Now, in order to write 450 in scientific notation, let's review real quick exponents. So if I have a number, let's say x to the power of n, that is equal to x times x times x dot dot dot. And you've got, n x's multiplied together. So for instance, 10 squared is 10 times 10, which is 100. Now 450, that's 4.5 hundreds. And so we could write 450 as 4.5 times 10 to the 2. And this is the scientific notation way of writing the number of snakes used in the filming of Snakes on a Plane. Now, that would be silly, it's just easier to write 450. You're not going to use scientific notation for that. But I just wanted to explain the concept here. Now this number, 330 million, let me double check that I've got that right, 330 million, that is about the current population of the United States. And so the way we can write that in scientific notation is we look at how many decimal places. 450 was 4.5 hundred, and 100 was 10 to the 2. This is 330 million. What is a million? A million, by definition of the word, this is what a million means, is one with 6 zeros after it. And that is 10 to the power of 6. So we can write 330 million as 330 times 10 to the power of 6, the number of people in the United States. We could also write that as 3.3 times 10 to the 8 times 10 to the 8. Because there's an implied decimal point right here after the 330. So if I move the decimal point 2 places to the left, that makes it from 330 to 3.3. That's 100 times less. So I have to make this 2 powers greater to compensate. So 330 times 10 to the 6 is the same thing as 3.3 times 10 to the 8. And, I kind of prefer this, actually, because the 10 to the 6 is a million. So you can just say 330 million. Just when you see 10 to the 6, you say the word million. 3.3 times 10 to the 8 is a little less elegant. But you may have, if you've learned about scientific notation before, you may have learned that the number in front, the coefficient it's called, should be between 1 and 10. It doesn't really matter if you want to keep it 10 to the 6, because then you can say million. That is perfectly fine. So let's go ahead and take a look at our astronomical examples here. There is an implied decimal point right here. And so how many zeros is that? I'm going to count back. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so 1 light year is 9.5 times 10 to the 12 kilometers. An astronomical unit. Here's our implied decimal point. Let's count back. 1, 2, 3, 4, 5, 6, 7, 8. So 1.5 times 10 to the 8 kilometers. Or if we only went 6 places, 1, 2, 3, 4, 5, 6 to there, we could say 150 times 10 to the 6 kilometers. In other words, remember, how do we pronounce 10 to the 6? We don't pronounce it 10 to the 6, we pronounce it million. So this is 150 million kilometers is one astronomical unit. The last one I'm going to leave for you. Go ahead and write, what is this? The mass of the Earth in kilograms. Go ahead and write that in scientific notation. And you can check your answer in the comments below, or talk to a friend to double check your answer.